Hello everyone, I am Asrar Ahmed and will be presenting the work Unsupervised Code Generations of Foreground-Background Segmentations from text-to-image synthesis. Text-to-image synthesis is one of the most important problems in generative approaches. The current trend of model focus is to make use of large-scale networks in training. Such approaches have grown in size by parameters and complexity like DAL-E, ImageGen, and COCO. The main focus of all such models is only on improving the quality of the generated images. We ask a simple question, whether text-to-image generative models are also capable of producing extra information that can be used for other underlying vision-related tasks. Along with realistic images, can we obtain any useful byproducts in an unsupervised way that will also benefit other computer vision tasks? Our approach generates images and foreground-background mask conditioned on text. The objective of our work is that given the text to the text-to-image synthesis model, it should output the image along with the foreground-background maps that are associated with the text as shown in the figure. Our approach is twofold. Firstly, improve the quality of the text-to-image synthesis. Second, and also produce high-quality foreground-background maps that can be used to train segmentation networks in weak supervisions. To achieve these, we propose a simple architecture involving co-segmentations between two image features simultaneously generated from the same text, but initialized with different noise vectors. Specifically, we propose a novel framework called Co-Segmentation Inspired GAN that accepts text as and encodes it into a sentence vector. Multiple sentence vectors are generated using conditioning augmentation techniques as proposed in stack GAN, and further, these sentence vectors are augmented with two different noise vectors to yield the two initial conditioning vectors. These vectors are transformed into low resolution spatial maps and then passed through multiple stages, where every stage consists of a spatial co-attention mask predictor, followed by upsampling convolution to finally output the generated images. Spatial co-attention mask predictor employs co-attention between two image features over the entire spatial dimension to indice a notion of co-segmentation and capture global information for prediction of foreground-background segmentation mask for each image. Further, predicting foreground-background mask on image-attended feature maps result in superior quality over maps predicted simply on image features. Apart from the advantage of being a useful byproduct, the prediction of the foreground-background mask allows the model to individually act on foreground and background to enhance the image quality. Spatial co-attention mechanism. The prediction of intermediate masks within generative models typically relies on single convolution naming. These approaches are similar to CBAM models. However, such approaches heavily depend on local receptive fields in image features for mask predictions, limiting its utilizations of global information within the image. To avoid this limitation, our proposed approach introduces generation of two images and implements spatial co-attention between their respective image features. This strategy aims to facilitate co-segmentation, enabling us to predict mask on image-attended feature maps that primarily highlight the common object present in both the images. We effectively integrate global information from both images by leveraging attention across all spatial locations between the images. Current approaches utilize these predicted intermediate masks for enhancing the underlying task by regulating the impact of image features. However, these masks are often only used for the foreground or the object of interest, limiting their scope in generative models. This limitation comes from the importance of both foreground and background in generating high quality images. In contrast, our approach utilizes predicted masks for foreground and background, leading to enhanced performance in text-to-image tasks and better mask generations. In our approach, we use a single and simple discriminator. For GAN loss, we use the proposed hinge loss, and use sentence and word contrasted loss to capture text-to-image alignment. We compare the proposed COS-GAN with current lightweight GAN-based models for text-to-image synthesis on CUP and COCO datasets. Our model achieves superior visual quality on CUP dataset. Our model does not use any extra network to improve text-to-image alignment, but only uses the discriminator to capture this alignment. So we notice a small drop in the R precision value. On COCO dataset, We achieve similar performance as that of SSA GAN. Our approach Our approach's ability to extract meaningful segmentation masks for the generated images can be seen as an added advantage over the other models. Compared to other approaches, for text-to-image synthesis, our COS-GAN utilizes significantly less number of parameters and still achieves competitive performance with extraction of foreground-background semantic maps for each image. On Oxford 10 dataset, there is a remarkable improvement on image generation quality, and all this while achieving high quality foreground background mask. Now, if the quality of the generated mask and foreground mask is exceptional, they can serve the purpose of training segmentation networks using weak supervisions. To evaluate the efficacy of the generated FGBG mask, we have trained unit in weakly supervised approach using images and mask generated by our COS-GAN for predicting segmentation maps for real images. We have evaluated the predicted mask on the standard test splits of the CUB and Oxford 102 dataset. The maps produced by COS-GAN exhibit superior quality over different unsupervised methods and represent a viable option for training various methods for training various models in weakly supervised learning scenarios. Compared to SSA-GAN, a text-to-image model which employs a segmentation network for mask prediction and addresses only the foreground, our proposed method surpasses it by generating FGBG masks of higher quality. So we summarize our work. We have proposed a novel GAN framework for text-to-image synthesis, which generates two images simultaneously and extract their FGBG mask using co-attention mechanism. The presented method has illustrated that predicting segmentation maps on image-attended features produce high-quality segmentation masks and improves the quality of image generated. We also propose a novel spatial conditioning block that focuses on dedicated conditioning to the foreground and background, further boosting the model's performance and prompting the network to generate meaningful segmentation masks. Thank you.